Welcome to this tutorial on transposing arrays with NumPy Transpose. In this video, we'll explore how to use the np.transpose function to rearrange array dimensions with advanced axis specification. This is a powerful technique for reshaping multidimensional data in NumPy. Let's start with the basic syntax. First, we import NumPy as np. The transpose function is called using np.transpose, which takes two parameters, a, which is the input array, and axes, which defaults to none. This simple syntax gives us flexible control over how we want to rearrange our array dimensions. The transpose function has two main parameters. The first parameter, a, is the input array that you want to transpose. The second parameter, axes, is a tuple that specifies the permutation of axes. When axes is set to none, which is the default behavior, the function reverses all dimensions of the array. Let's look at a two-dimensional array example. We create an array with shape 2 by 3, containing the values 1 through 6 arranged in two rows. When we apply np.transpose to this array, the shape changes from 2 by 3 to 3 by 2. The rows become columns and the columns become rows, giving us a matrix with 3 rows and 2 columns. Now let's see how transpose works with three-dimensional arrays. We create a three-dimensional array with shape 2 by 3 by 4 using np.rearrange and reshape. When we call np.transpose without specifying the axes parameter, it reverses all axes. The original shape of 2 by 3 by 4 becomes 4 by 3 by 2. This default behavior completely reverses the order of dimensions. Here's where transpose becomes really powerful. Using the same three-dimensional array with shape 2 by 3 by 4, we can specify exactly which axes we want to swap. By passing axes equals 1, 0, 2, we're telling NumPy to swap only the first two axes while keeping the third axis in place. The shape changes from 2 by 3 by 4 to 3 by 2 by 4. Understanding axes is crucial for using transpose effectively. Axes are numbered starting from 0, so the first dimension is axis 0, the second is axis 1, and so on. The axes tuple you provide specifies the new arrangement of these dimensions. Each number in the tuple represents which original axis should appear in that position in the transposed array. Let's summarize the key takeaways. First, when you don't provide an axes parameter, transpose reverses all dimensions by default. Second, by specifying a custom axes tuple, you gain precise control over the dimension order, allowing you to rearrange your array exactly as needed. This flexibility makes np.transpose an essential tool for array manipulation in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.